All right, so guys, quickly, just as the name implies, anytime you hear something is extra, you know that okay, this thing is outside. Anytime you hear that something is intra, you know that okay, this thing is inside. Okay, so we are going to talk about extravascular and intravascular hemolytic anemia. All right, so these two types are basically what a type of anemia that is resulting from, um, how will I put it? Lysis or breakdown of blood cells. Okay, so now breakdown of blood cells could be occurring inside the blood vessel, which is intravascular, or breakdown of blood cells could be occurring in organs or outside the blood vessel, which is known as what the extravascular hemolysis. Okay, we'll be talking about the two concepts, and from that you guys will get to see what the differences. Okay, of course the similarities is that the two of them are what types of hemolytic anemia. So now we see that what hemolytic anemia can be classified into two main categories, all right, based on the location of red blood cell destruction. Okay, so red blood cell destruction could be occurring outside the blood vessel, that's in an organ, and this is known as what extravascular. Or the destruction of red blood cells could be occurring inside the blood cell, and this is known as what intravascular. Okay, so now picking up the extravascular, now we'll talk about it, the definition, characteristics, examples of conditions that can cause extravascular, then we'll go into intravascular. Okay, we're talking about the extravascular now. We say that what blood cell production occurs, okay, sorry, blood cell destruction occurs outside the blood vessels, all right, and this is primarily in organs like the spleen, the liver, and the lymphoid nodes. Okay, and this extravascular hemolysis is characterized by what? Removal of defective or damaged red blood cells from circulation by macrophages in the spleen and liver. Okay, there's increased bilirubin production leading to jaundice. All right, because there's breakdown of red blood cells, there's increased what? Bilirubin production. All right, now because the spleen is being engorged, all right, the spleen is being what? Rushed out. Will I say the work on the spleen is what? Overloaded. All right, the spleen will become enlarged. That's what we call splenomegaly. Okay, so enlarged spleen is what we call splenomegaly. All right, the examples of conditions that can cause this extravascular hemolysis include what? Hereditary spherocytosis, hereditary erythrocytosis, and the autoimmune hemolytic anemia. Also, sickle cell disease can cause this condition. All right. Then talking about the intravascular hemolysis, which is basically what? Destruction of red blood cells inside the blood vessel. Let's have it. And this one is basically what? Red blood cell destruction that occurs within the blood vessel. It's characterized by what? Direct destruction of red blood cells in circulation. There's hemoglobin release into plasma, all right, leading to hemoglobinemia or hemoglobinuria. Okay, there's no splenomegaly in this one now. Okay, the examples of conditions that can cause this intravascular hemolysis include what? Glucose 6-phosphate dehydrogenase deficiency, paroxysmal nocturnal hemoglobinuria, there's disseminated intravascular coagulation, and severe burns. All right, all these conditions can basically cause the intravascular hemolysis. All right, so both type of these conditions present with anemia, jaundice, fatigue. All right, but intravascular hemolysis is often more severe and may lead to what? Hemoglobinuria. That's basically what? Hemoglobin in urine. Okay, so that's just basically what ending this, we said that what? According to the site of hemolysis, according to the location of blood cell damage, blood cell damage could occur outside in organs, or blood cells damage could occur what? Inside in the blood vessel, right? Named what? Extravascular and intravascular hemolysis. Right? So guys, that's it about what? The different types of what? Hemolytic anemia based on what? The site of blood cell damage. So that's it guys, and bye for now.